Thank you very much, Aoife. Good morning, everyone. Thank you very much for joining us for our webinar today. As Aoife says, I am the Technical Office Manager here at Visqueen. So if you have any queries, if you require any technical assistance, then me and my team will be your first point of call. So yeah, please get in touch with us. But yeah, we'll move on to the presentation and the webinar for today. So today we are here to have a look at our Visqueen Zedex Non-Combustible DPC cavity tray system. A little bit about Visqueen, if you don't know who we are. So Visqueen are a market leader in the manufacture and supply of damp proofing, structural waterproofing and ground gas protection systems. We supply the widest range of DPC cavity tray systems in the UK. The brand for our DPCs is Zedex. So within that range, we have the Visqueen Zedex housing grade, the Visqueen Zedex CPT high performance DPC, the Visqueen high bond Zedex high bond DPC, and then we have our Visqueen Zedex non-combustible DPC, which is what we're here to talk about today. We offer technical support at every stage of the specification and supply chain process. And in conjunction with the National Masonry Academy, Visqueen have developed a registered installer scheme for brickwork contractors. So if anyone on the call today would be interested in the registered installer scheme we have, then please contact ourselves or the National Masonry Academy for more information or potentially get yourselves booked on. So the objectives of today's webinar is to have a look at some background information, have a look at the terminology that's used around these particular products. We'll take a look at some of the industry guidance that's available and also building regulations. We'll have a look at the components of the Visqueen Zedex non-combustible DPC cavity tray system. We'll briefly look over the system installation and how our products are installed. And then we'll have a very quick slide regarding the features and benefits of our Visqueen Zedex non-combustible DPC system. First, let's review some key terminology in the industry and what is required by the building regulations for England. So Visqueen market a wide range of damp-proof courses, or DPCs as they're known. They are inserted into the wall structure and they stop the movement of moisture from one part of a structure to another. In the case of the lower right image that's shown on the screen now, damp rising up the wall would be stopped by the linear DPC that is installed typically 150 mil above the external ground level. On some occasions, the DPC is draped across the cavity, stepping up a minimum 150 mil from the outer to the inner leaf, like we see here over the lintel. When used in this way, the DPC is given a specific name and it's called a cavity tray. So a cavity tray, in essence, is just a wider width of DPC, generally 450 mil or bigger. And any rainwater, the purpose of this cavity tray is that if any rainwater seeps through the outer leaf of the wall, it will trickle down the cavity face of the outer leaf. It's collected by the tray and diverted to weep holes in the outer leaf. When used above a window or a doorway, it is referred to as a discontinuous tray, extending beyond the ends of the lintel. The rainwater is prevented from running off the ends of the tray by creating stop ends with the DPC material itself being turned up into the height of the outer leaf perpend, so the vertical joint in the masonry, or by using preformed stop ends. When used above items that continually bridge the cavity, so for example fire stops, brickwork support angles, cavity tray is continuous and runs right the way around the building. When it reaches corners, preformed corner units should be used and they should be suitable to match the profile of the cavity tray. Preform units are factory manufactured three-dimensional shapes used for damp protection at complicated cavity tray junctions in the masonry wall application. Some of the units that are manufactured can be reversible. And this particular image here in the middle is showing a preformed built-in cavity tray corner. So we mentioned the word profile, and what do we mean by that? We mean the profile of the cavity tray within the section. So if we have a look at this drawing over here, we can see here that the DPC starts in the inner leaf and it is built into the masonry. It comes out into the cavity horizontally through the insulation. It slopes down through the open cavity, and then it comes out in the outer leaf. Sorry. Where we don't have a masonry, brickwork, blockwork inner leaf, we might have a steel frame system, for example. Cavity trays are surface fixed. So the drawing over here on the left-hand side shows a cavity tray being surface fixed to a steel frame system. This particular section that we're showing here shows the cavity tray actually being stapled to the sheathing board. That we do have another method whereby it can be mechanically fixed with fixing strips and suitable fixings for the substrate. Again, over on the right hand side, you'll see here we've got some examples of typical preformed cavity tray units. They differ slightly to those before because the top flange, as you may call it, actually goes straight up rather than being flat, so it can be surface fixed to the inner leaf. And sometimes contractors, brickwork contractors, builders on site will prefer to take the cavity tray through the insulation horizontally rather than sloped. Just makes it slightly easier cutting the insulation. Where this is the case, the preformed units will change because we will have a ledge on the preformed unit to suit where the cavity tray is going to pass through the insulation. So we've talked about preform units. Both the British Standard Code of Practice and warranty provider standards state that preform cavity tray units should be used at complicated junctions. The British Standard 8215 of 1991 in section 5.5 tells us that forming an effective barrier to damp in cavity walls may give rise to complex three-dimensional details, which it is recommended are prefabricated. And then we have a section taken from NHBC standards that tells us that cavity trays should be preformed where used at complicated junctions. Next, we'll have a look at some of the terminology that is used in the industry when it comes to resistance to fire and products that are used in the external wall buildup. So the first one we start with is flammable, and we move on to inflammable. Now, these two actually do mean the same thing. Why do they mean the same thing? So in the English prefix, in often means not, as in active and inactive, leading to people mistakenly assuming that inflammable means not flammable. However, the in inflammable is an intensive Latin prefix meaning in or into. That means to cause to be on fire. So actually, flammable and inflammable do mean the same thing. The opposite to both those words is non-flammable, which is our next word on the terminology list, and that means that the product doesn't catch fire easily. A flame retardant product is a substance that can be added to combustible materials to help prevent or slow fires, typically used on furnishings, textiles, and items within the home. Fire retardant refers to a substance that is used to stop or slow the spread of fire. And then we have non-combustible, which refers or means that a product is made of a material that does not burn if exposed to fire. So that's some terminology that's used. What are the requirements of building regulations for England? Here we've got an extract that's taken from Approved Document B, Volume 1. As we can see, I'll just read through the statement that is here. So for fire safety, Approved Document B, Volume 1, Requirement B4, referring to the external spread of fire, Regulation 7. Tells us that subject to paragraph 3, building work should be carried out so as that materials which become part of an external wall or specified attachment of a relevant building are of European classification A2-S1 D0 or A1, and that's classified in accordance with the reaction to fire classification. Clause 10.14 sets out the requirements with some additional context. So let's have a look at some of the highlighted points here, and then we will move on to have a look at what is meant by the A2-S1 D0 that is mentioned here. So we can see that the requirements in the regulation applies to any building with a story at least 18 meters above ground level, as measured in accordance with the diagram in diagram D6 in Appendix D, that contains one or more dwelling, contains an institution, or contains a room for residential purpose. It states that it requires all materials which become part of the external wall or specified attachment achieve Class A2-S1 D0 or Class A1 in accordance with BS EN 13501-1. And that's other than those that are exempt by Regulation 7. Little note to add is that the above includes student accommodation, care homes, sheltered housing, hospitals, dormitories in boarding schools, hotels, hospitals, and boarding houses. If you require further information with regards to relevant buildings, contact us for a chat, or you can have a look at Regulation 7.4 for that information. So I've mentioned fire classification A2-S1 D0 a fair bit. So what does that actually mean if we break it down into the different sections? So the A2 refers to how much a material contributes to the spread of flame. A product that has a fire classification of A1 or A2 are non-combustible materials. Anything with a fire classification B, D, C, or D means that the contribution to fire ranges from very little to medium. And if the product has a fire classification of E or F, it will have a high contribution to fire. We move on to the S1 part of the fire classification. So the S part relates to the total smoke propagation during the first 10 minutes of exposure, and that determines a smoke index. So if a product has a classification of S1, it means that a little or no smoke is produced during the first 10 minutes of exposure to fire. An S2 rating means that there'd be quite a lot of smoke, and an S3 means there would be substantial amount of smoke. And the last part, the D0, D part relates to the flaming droplets and particles during the first 10 minutes of exposure. And the index is that if it is a D0 product, then there will be no flaming droplets or particles. If it's a D1, then there'll be some, and D2, there'll be quite a lot. Have a look at some of the snippets taken from building regulations and approved document B with regards to products being installed into the cavity walls and the requirements for them to be have a fire classification. There are some exemptions, and they are that cavity trays, when used between two leaves of masonry, it doesn't require the products to have a fire classification rating. Insulation and waterproofing materials used below ground level or up to 300 mil above that level are also exempt. Membranes are exempt, and also seals, gaskets, fixings, sealants, and backer rods are exempt. I've mentioned relevant building in a previous slide. So what is meant by a relevant building? A relevant building means a building with a story, not including rooftop plant areas or any story consisting exclusively of plant rooms, at least 18 meters above ground level, which contains one or more dwellings, or contains an institution, or contains a room for residential purposes. So while the absolute ban officially starts at 18 metres, statutory guidance for some residential buildings between 11 and 18 metres effectively limits combustible materials for cladding and balconies to the highest safety standard of A2-S1D0 or A1. So this is referring to products and insulation products, filler materials, metal composite panels, etc., that could be used in the external wall construction. And looking at approved document B, requirement B4, clause 10.10, there is a section in there, and this section refers to in buildings that require a residential purpose with a story of 11 meters or more in height. Balconies should only contain materials achieving class A1 or A2-S1D0. So generally, DPCs don't tend to be used in balcony areas. However, if a DPC is required, then it will need to have a fire classification of A1 or A2-S1D0. So that's the terminology. We've had a look at the building regulations and the requirements for materials used in external wall construction of buildings over 18 meters, sorry. So we'll now have a look at the Visqueen Zedex Non-Combustible Cavity Tray System. System is made up of a number of components. So we have the flexible DPC cavity tray material. There's a mastic that is used to seal the joints of the DPC. Preform cavity tray units, we have flexible units and we have rigid stainless steel units. Cavity tray joint supports, and then our fixing strip for mechanical fixings where surface fixed. So the Visqueen Zedex Non-Combustible DPC material is available in standard roll sizes of 100mm, 150mm, 225mm, 300mm, all the way up to 900mm, and all the rolls are 20 meters in length. If you do have a requirement for a roll width that isn't one of our standards, then please contact us because we can certainly have a look to see if it is possible to provide the material in a different width. Visqueen Zedex Non-Combustible DPC is a highly flexible, lightweight DPC. As you can see in the bottom left-hand corner, one of our technical support managers has taken a piece of the material and screwed it up and folded it up into a nice little ball there. That's just to show how flexible the material is. And the installation is very rapid when surface fixing to weather defense sheathing boards. Visqueen Zedex mastic comes in a 380mm cartridge. It's used to seal the laps of the joints in the DPC material. So there's no tapes required in this system. All lap joints are a minimum 100mm wide. One cartridge is sufficient to seal approximately 6 laps in the DPC and the cavity tray units where applicable. And again, it's very rapid to install using a standard skeleton gun. Our Visqueen Zedex non-combustible flexi units are manufactured from the DPC material. Used at internal and external corners, and these are an off-the-shelf product. They're supplied in boxes of 4, and they suit a variety of cavity widths. So you'll see there they range from 40mm to 100mm, all the way up to 250mm to 300mm. Just a little image here to show those flexi units in place. If the flexi units are not suitable for your project requirements, we can manufacture preform units in stainless steel. They can be used at complicated non-standard cavity tray junctions, and they're designed using architect's drawings. These bespoke units are made to order. Here there's a picture and a drawing of a unit that we have made for a project that is currently on site. And as you can see, this particular junction at a doorway was very complex, and a flexi unit was just not going to be suitable. Visqueen DP joint supports are manufactured from stainless steel. They support cavity tray joints in line with NHBC standards, and the British Standard 8215 of 1991, section 5.5, sorry, which states that any necessary joints should be fully supported. These DPC joint supports can be used with all of our DPC cavity tray systems, and they are available in a pack of 10 off the shelf. And the bottom picture there on the left hand side shows how they can be bent and formed on site to suit your cavity profile. And lastly, in the components for the Visqueen Zedex Non-Combustible DPC cavity tray system, we have our non-combustible fixing strips. There is stainless steel strip that is 1.24 meters long. They come in a pack of 17. They do have pre-drilled holes ready for the fixings. They will be used with appropriate stainless steel fixings when securing a cavity tray to the inner leaf of a concrete slab edge or masonry construction. And one pack of 17 fixing strips is required per roll of DPC. So that's the system. We'll now have a look at the installation of Visqueen Zedex Non-Combustible DPC cavity tray system. So just like all other flexible DPC products, Visqueen Zedex non-combustible cavity trays are installed following the principles laid down in the warranty provider standards and the British Standard Recommendations Codes of Practice. It is these industry documents that stipulate key points relating to DPC cavity tray installation systems, and we've already seen extracts earlier in the presentation from NHB standards and British Standard 8215 relating to the use of preformed units and complicated junctions. But what about supporting DPC cavity tray lap joints? So NHBC standards section 6.1.17.1 states that cavity trays should be one continuous piece or, where necessary, have sealed or welded joints which are provided with rigid support and are lapped at least 100 millimeters. And the British Standard 8000-3 of 2020 in section 7.1.18a says that we should use cavity trays wherever practical in continuous lengths. If a joint cannot be avoided, a rigid support of suitable material should be used at the position of the joint so that solid bonding is provided. Overlaps in joints of DPCs are a minimum 100 mm and seal with appropriate jointing compound. So where should cavity trays be used? They should be used and stepped up a minimum 150 mm from the outer to the inner leaf to form a cavity tray. They should be provided over all openings unless well protected, for example, by overhanging eaves. They should be provided under all porous or jointed sills. Provided over items bridging the cavity, for example, masonry support angles, cavity fire barriers, lintels, etc. Provided with prefabricated units at complicated junctions, and provided with the stop ends when discontinuous. So discontinuous cavity trays are installed above wall vents, lintels, etc. Stop ends prevent water from running off the end of a discontinuous cavity tray and divert the water towards weep holes. The simplest way is to create a stop end is to fold up the ends of the discontinuous tray to the full height of the perp ends and secure them in place. Preformed cavity tray units are available if required. So we move on to the installation of a continuous cavity tray, and we'll also have a look at the lap joints. So step one is that we bend the Visqueen DPC joint support to the required profile and secure the secure lap locations. Then we install Visqueen Zedex non-combustible DPC cavity tray material to the weather defense sheathing board, mechanically fixing it to the board with 12 mm stainless steel staples at 150 mm centers and a minimum of 20 mm from the top edge. Quick little video there just to show you how quick and easy it is to staple the Visqueen cavity tray material into place. So once the first piece of material is in place, you'd apply Visqueen Zedex mastic at the lap joint location, sufficient to form a 100 ml fully bonded joint. After the mastic has been installed, we apply the adjacent Visqueen Zedex Non-Combustible DPC. The lap must be rolled to ensure that the mastic has been spread across the full width and forms a 100 ml fully bonded joint. And then apply a small amount of mastic along the lap edge to seal it. Then continue stapling at 150 ml centers, and in the outer leaf, bed the DPC cavity tray in mortar, and install fresh mortar and masonry above the DPC. So that was the installation of the material. We'll just quickly have a look at some of the features and benefits of the Visqueen Zedex Non-Combustible Cavity Tray System. So the system is BDA Agremont certified. The general installation is very familiar to brickworkers. The DPC product itself is highly flexible. It's very rapid to install. It's a lightweight system, typically for a 600 ml wide roll. That roll itself is around 8.3 kilos. Product is available in a variety of widths. The DPC has all necessary system components for complete and easy installation on site. It's an off-the-shelf product, and also off-the-shelf preform units are available for complex junctions. Our products are stocked by specialist distributors, and we are here to support you all with your design and installation of the Visqueen Zedex Non-Combustible Cavity Tray System. So we'll just very briefly have a look at the objectives that we set out at the beginning to make sure we have covered those. So we certainly have had a look at the background and the requirements for the use of non-combustible materials, the terminology, industry guidance, and the requirements for building regulations. Had a look at the system, so I've made you aware of all the products that are in the system. Had a look at the system installation, and also the system features and benefits. So that is the end of the webinar, the presentation today. Thank you very much for joining.